Welcome all. In this lecture, we will discuss about electrical analogy of mechanical systems. So first we can discuss force voltage analogy. So consider a mechanical system with mass m. The dashboard is having a frictional coefficient B. Spring is having the spring constant K. Displacement is x. The applied force is F. So the force balance equation is F equal to m d square x by dt square plus b dx by dt plus kx. So next consider a electrical system with a voltage source as input and a series RLC circuit. So I is the current flowing through the circuit. Then applying KVL, we can write as the total voltage V is equal to R into I. This voltage across L is L di by dt plus voltage across capacitor is 1 by C integral I dt. But current I is dq by dt. Q is the charge. So substituting this, we can write this I become dq by dt, this di by dt become differential of this, so d square q by dt square. Then this integral I dt become q. I dt become integral I dt. I into dt is dq, so it is integral become q. So rearranging this, we can write as L d square q by dt square plus R dq by dt plus 1 by C q. So we can compare these two equations. So this is the mechanical equation, this is the electrical equations. So comparing this, we can say that here the force is analogous to voltage F and V. Here force is the input, here V is the input, and here mass M is analogous to inductor L. Here the B dashboard is analogous to resistor R, and the spring K is equal to 1 by C. So K is the reciprocal of 1 by C. Capacitor, reciprocal of capacitor, so 1 by C. And here it is displacement X, here it is charge, so displacement is analogous to charge. So this is called force voltage analogy of mechanical system. So we can convert the mechanical system into electrical system. Okay, that is the thing. That is the analogy. Means this here it is force is analogous to voltage, so it is called force voltage analogy. And we are obtaining this by applying KVL in the equation. Next is force current analogy. For that, consider the same mechanical equation, mechanical system, and the equation is this one. So consider a parallel circuit with current as input I, and we can apply the KCL here. So the total current I will be equal to current through R, current through L, current through C. So I, the total current I, then this is voltage V, node voltage is V. So the current through R is V by R, current through L is 1 by L integral V dt. V is equal to L di by dt, so it become 1 by L integral V dt, and this is C dV by dt, current through C. So again V is actually d phi by dt, where phi is the flux. So we can replace V. So this V become 1 by R d phi by dt. This integral V dt become integral V dt will be integral of d phi, that is phi. Then this become integral of V, so it is become d square phi by dt square. So this will be like this: I is equal to C d square phi by dt square plus 1 by R d phi by dt plus 1 by L phi. So if you are comparing these two, we can say that here force is analogous to current. Force is analogous to current input. Mass is analogous to capacitor. Dashboard is analogous to reciprocal of resistor 1 by R, and spring constant K is analogous to reciprocal of inductor 1 by L. So displacement, here it is displacement X, so it is analogous to flux here. So this is force current analogy. So it is applying by KCL. Here the force is analogous to current, so it is called force current analogy. We can convert this mechanical system into equivalent electrical system. It will be in parallel. So now how we can convert a complex mechanical system to electrical system using force voltage analogy. Then here there are 2M, so there will be two meshes. So we have to consider this one, mechanical system, electrical system. So there are two meshes M1, M2. So we have to consider two meshes M1 and M2 for M1, M2. And if you are looking here, this B1 K1, this term is common to these two. So this will be so analogy term, electrical elements analogous to this B1 and K1 will be both associated with these two meshes. So it will be here. So for B1 it is resistor, so having resistor value B1. Okay, and K1 is also associated with both M1 and M2, so it will also be associated with both meshes M1 and M2. So K1 is 1 by C, so it will be 1 by K1. Okay, a capacitor having value, it is reciprocal, so 1 by K1. And this is the two elements which is associated with both. So here we have to draw these two elements. Then we can consider this first. So first mesh. So first M1 input is f of t. So here will be input f of t to be voltage source having the same value f of t. Then another term is this m square mass term. So it will be inductor. Okay, here it is inductor. So it will be inductor with value M1. Then next here. So for M2, the individual terms, the common terms are this, and other terms are M2 term. So that is inductor. So M2. Another one is this K2 and B2. So K2 is capacitor. Term is 1 by K2 since it's reciprocal. And dashboard is resistor. So a resistor with value B2. So these are the elements. So we can complete the circuit. So this will be the electrical equivalent of or electrical analogous system to this mechanical system. This is equivalent to this. So we can apply or analysis this electrical system instead of analyzing this mechanical system. This is the force voltage analogy equivalent circuit of this one mechanical system. Next is force current analogy of this same mechanical system. So we have to consider this. So again here we have to apply the intrinsic force current analogy. We have to apply the nodal equations. So there are two masses, so there will be two nodes. We have to consider two nodes, and these two elements are associated with these two. So this will be in between these two nodes. So B1 and K1. So first B1 means reciprocal. So it is in between these two nodes, 1 by B1, since it is reciprocal. Okay. Then next one, this spring. So spring is also in between these two. So we have to draw in between these two nodes. So it is also reciprocal. So 1 by K1. So these two elements. Then we can take this first M1. So it is first node here. So we have to first f of t. So it is a current source. So we have to mark a current source from this node to reference. Then the term M1. So M1 is capacitor. So a capacitor having value M1 from this node to reference. So this is over. Next this one. Common elements are this. Other terms are M2, K2 and B2. So M2 will be a capacitor. Same value. Then spring will be B2 will be a resistor having reciprocal value, so 1 by B2, and spring will be inductor, so 1 by K2. So this is the force current analogy of this given mechanical system. So by this we can convert the mechanical system to equivalent electrical system by both force voltage or force current. So with this we can wind up this session. Thank you.